Imagine a place where time flows backward. A place where nothing can enter, but everything must escape. A cosmic fountain that spews energy and matter. The perfect mirror of a black hole. This is a white hole. It might sound like science fiction, but it's a real solution to Einstein's equations. And if it exists, it could explain black holes, the Big Bang, and the ultimate fate of the universe. You're watching the Science Hall of Fame, where the cosmos gets curious. Everyone knows what a black hole is, a collapsed star that's so dense, not even light can escape. But hidden in the math that gave us black holes is another kind of object, a white hole. It's what you get when you take the equations for a black hole and run them backward in time. Instead of pulling everything in, a white hole pushes everything out. Matter and energy can leave it, but nothing can enter. From the outside, it would look like a brilliant explosion, then vanish, forever sealed off. So far, white holes are purely theoretical. We've never seen one, but the equations don't forbid them. In this episode of the Science Hall of Fame, we'll explore the strange math and even stranger possibilities behind them. To understand why white holes matter, we need to take a detour into the weirdness of black holes. When something falls into a black hole, its information, its mass, charge, even quantum state, is trapped, or is it destroyed? That's the information paradox, and it's one of the biggest mysteries in modern physics. According to Stephen Hawking, black holes slowly leak energy, what we now call Hawking radiation. Over time, they evaporate and disappear. But if that radiation is random, the information inside is lost, and that breaks a fundamental rule of quantum mechanics. Information can't be destroyed. So, where does it go? One radical solution: when a black hole finishes evaporating, it doesn't just vanish, it bounces and becomes a white hole. Here at the Science Hall of Fame, we love ideas that bend the rules of the universe, especially when they might fix the ones we've broken. But white holes might be more than just cosmic trash cans. They could be part of something even stranger: wormholes. Some solutions to Einstein's equations connect black holes and white holes via a tunnel through space-time. A wormhole. Matter enters the black hole and exits the white hole somewhere else, maybe on the other side of the galaxy or in another universe. But there's a catch. These wormholes collapse almost instantly. To keep them open, you'd need something exotic, like negative mass or quantum matter. So while wormholes and white holes are mathematically possible, they're probably not practical time machines. Still, they offer tantalizing clues about how space, time, and gravity are stitched together. On the Science Hall of Fame, we don't just explain the science, we chase the questions that still keep scientists up at night. Speaking of bounces, what if our entire universe came from a white hole? Think about it. The Big Bang started from a single point of infinite density, a singularity, just like a black hole. But instead of sucking things in, it exploded outwards, just like a white hole. In one theory, called loop quantum cosmology, the universe didn't begin from nothing. It's the result of a big bounce. A previous universe collapsed into a black hole, which turned into a white hole and gave birth to ours. A cosmic recycling program. One universe dies, another is born. If that sounds wild, don't worry, you're in the right place. This is the Science Hall of Fame, and we love asking the biggest questions in the universe. So, are white holes real? Maybe we haven't found one, and we might never be able to. They might be microscopic, fleeting, or exist only in the early moments of the universe. Or maybe they're mathematical ghosts, beautiful but imaginary. But even if we never see a white hole, the idea pushes science forward. It forces us to confront the deepest questions we know how to ask. Where does information go? Is time reversible? Was the Big Bang the beginning, or just another chapter? In the end, black holes show us how little we know. White holes show us how much more we might discover. And here, on the Science Hall of Fame, that's what it's all about. The universe is full of mysteries. Some hide in plain sight, others wait in the dark. But every now and then, we find a mirror, and it shows us not just where we're going, but where we've been. Subscribe to the Science Hall of Fame for more deep dives into black holes, time, and everything in between.